Hello and welcome to Understanding Numeric Calculations in DAX. My name is Markus Ehrenmueller-Jensen and I hope you enjoy this session. Don't forget to explore what PAS also offers besides this virtual event this week. And don't forget to fill out the session evaluations. We speakers want to hear what you thought about your sessions so we can improve our sessions. And you can win a prize. So my name is Markus Ehrenmueller-Jensen. As you might hear from my accent, I'm from Austria, where we speak German. I am the founder and BI architect at Savory Data, and I'm very active throughout the community. So I'm proud to have all those badges there. And there's also a book out there, Self-Service AI with Power BI Desktop, which I really recommend to read. DAX. What is DAX? DAX is the data analysis expressions, sometimes also referred as the data analytic expression, and it was born with Power BI for Excel, which was an add-in back in Excel 2010, and keeps up living in Power BI and Analysis Services Tabular model. So the DAX was invented after Excel, SQL, and MTX. So the authors of DAX just copied and shared and reused stuff and functionality and ideas and concepts from Excel, like function-based syntax. 100 functions are the same like in Excel. SQL with the concept of having relational functions and row context, and from MTX where we know measures and we do not have to write any joins because they're implicit done, and filter context. DAX is a language for both measures and calculated columns, like we will learn today in this 60-75 minutes, and is also used for calculated tables and row level security and queries, but we will only talk about measures and calculated columns in this talk. The syntax is rather easy. It's like functions, and then you call functions, and the functions get parameters, and those parameters can be functions as well. If you know Excel and formulas there, you will pretty easy grab the syntax of DAX. The thing is that the semantic is rather complex, and this makes it hard for beginners because you're easily overwhelmed by the complexity of the functions. But on the other hand, this allows for powerful computation. So the farther you get with DAX, the more you will enjoy the complexity. For this talk, I took 3 calculations, and just to make sure that everybody's aware how those formulas are behind those measures. So one is the sales amount. If we have the price and the quantity given, then the sales amount is calculated as the price times quantity, and then we sum up those price times quantity to get the sales amount. Then we will talk about the margin. The margin is calculated as sales amount minus the total cost. That's the margin we can live off with, and we can also calculate the margin in percentage. That means in percentage of the sales amount. So margin divided by sales amount. In case you're not sure about those formulas, please take a screenshot right now and keep it on a separate window so it's you have it at hand, so we can concentrate on the DAX syntax and not so much on the formulas. Let's start with calculated columns. Calculated columns are written or referred to by convention with the table name and the column name. You write the table name in single quotes and the column name in brackets. You should always specify the table name, and you will learn why later in this talk. Despite the name calculated column, it is calculated row by row. So we call like there's a row context, and the result of this calculation is persisted into the model. That means the more calculated columns you have, the bigger the Power BI file will be, the bigger the memory footprint will be, and those calculations are refreshed when you refresh the model. So if you load the data again to your model, then also the calculated columns will be refreshed. So refresh will take longer when you have calculated columns. The data type is determined by the formula, and of course you can change it to your like. And we will concentrate on numeric calculations. So we'll not talk about the wide range of like text functions or statistic functions. We will concentrate on what's so special about numeric calculations. If you have calculated columns in your model and connect to this model via, for example, Excel, then you cannot move those columns into the value of section of a pivot table. This is just not allowed. On the other hand, Power BI, in Power BI you can do that, and the reason for that is because Power BI creates an implicit measure behind the scenes for you, and this is driven by the default summarization. The measure itself is invisible, so it's sometimes hard to explain to beginners that there is something we cannot see, but just trust me, there is an implicit measure. And as mentioned, we control this by the default summarization. So what's the default summarization? Default summarization is a model property of the column. So once you can change this in the model for the column. So we have the sum, average, minimum, maximum, count, and count distinct available. And you can also change it per visual. So even if it's like a sum in the model, you can show an average in your visual. And funny enough, the elements are almost the same. So like sum, average, minimum, maximum, count, and count distinct are, the order is like exchanged in the model and in the context menu of the visual. And then we also have the standard deviation, variance, and median only to select in the visual, but not when you model your data. So when we select something there, then Power BI will implicitly create a measure over the expression of the calculated column. That means if we selected sum, then we get like the sum of the results of this calculated columns expressions. First calculated column is sales amount. Remember, sales amount is price times quantity. That means that we're referring to other columns, and by convention we always mention the table name in single quotes. Sales price times sales quantity. And if we take a look on my very simple example, this is a whole sales table, only consists of 4 rows. So we have 1st of July, 2nd of July, and 3rd of July, and we have different prices and quantities. So on 1st of July we had the sales with price 10 and a quantity of 3, so we end up with 30 as the sales amount. 20 times 1 is 20, 30 times 4 is 120, and 100 times 5 is 500. If I show this result in a visual, then most probably we will also have a total at the end of the table, and this is calculated via the implicit measure. So the 670 are indeed the sum of 30 plus 20 plus 120 plus 500. So this is not calculated inside the calculated column, but this is calculated with the help of the implicit measure. If we think about sales margin, remember sales amount minus the total cost is the margin, and we calculate easy again in a calculated column. Again, only a couple of lines here. So 50 minus 40 is 10, 120 minus 75 is 45, 500 minus 350 is 150, and then the 205 at the end in the total. Again, an implicit measure is in place, summing up 10 plus 45 plus 150, summing up 205. Of course, in this case, we could also calculate it like 670 minus 465, but this is not the way a calculated column is calculated. It only calculates the column, the column for the rows existing in the table, and for a total we need the implicit measure. Easy as that. Let's take a look on the margin. The margin percentage is the margin divided by the sales amount. And if we calculate this, we see like 5 divided by 20 is 25, 5 divided by 30 is 16%, 45 divided by 120 is 37, and 150 divided by 500 is 30%. Remember what the margin is. The margin is what we earn after we subtracted the costs. So if we like earn 100 euros, dollars, whatever, and have cost of 90, then the margin is 10. The margin in percent is the margin divided by the sales amount. So 10% in the case just described. So the margin can never be 100 except for some industries which like earn money, like recyclers. They earn money for collecting the garbage and they make something out of that and selling it again. They have like maybe a margin bigger than 100%, but the usual industries don't. So we have 109 at the end here, and the reason for this 109, hopefully you understood everything so far, then you can explain it because there's an implicit measure in place. So implicit measure is now summing up those percentages to 109. And of course, this does not give any sense. We cannot calculate the margin in percent by adding up the percentages. So if we go to my demo file here, and we take a look on the margin in percent, then we can see that like we are in trouble with the 109 because this is summing up. Some people at this situation suggest that we calculate it like an average, not summing up, but calculate an average. Let's take a look how this would look like. So I can go there, mark the table here, and then change the margin in percent that the default summarization should be average. When I choose this, of course the number changes. It's going down to, let's go there, 27 something. Is this the right number? How can we check? We would expect that the margin is always the margin divided by the sales amount. So 10 divided by 50 is 20%. So for the total, we would expect 205 divided by 670. So let's calculate this. divided by 670 equals 30.6%. So 27 would be wrong because with the 27 we are calculating like the average of those numbers, but we do not replicate the formula like margin divided by sales amount in the total. So what we should calculate is like the total of the margin divided by the total of the sales amount to get the 30.6%. So how can we do this? We can't do that with calculated columns. So we have to reach out to measures. What's a measure? A measure by convention we referred without the table name. So we just write the name and omit the table name. I visualize measures that I think of measures like they live detached from the tables. Of course, I have to create a measure inside the table, but this is only for the UI because in the field list, I have to find the measure somewhere. It's connected to a table for UI reasons. But for a calculation perspective, it's not necessarily connected to a certain table. I can move the measures around, define it in one table, in another table. The result will always be the same because the measure lives outside of the tables. So it just looks at the whole model from like an outside perspective. And the calculation is influenced heavily by filters. So because it looks at the whole sales table, for example, most probably never there will be a chance that I get the whole sales table. Most probably it's always filtered on some years, it's filtered by territories, it's filtered by product categories, and so on and so forth. So there's one calculation, but for a formula, but for a certain calculation, it's influenced heavily by different filters. And there's lots of possibilities for filters in Power BI. We have slicers, we have the cross filters. When I click on a visual, it filters the other visuals. We have page filters, rows and columns in the pivot table. So the measure itself is not done row by row, but has to be calculated for an aggregated version of the numbers, unless we explicitly demand so. So we can demand that it's calculated row by row. We will see this in a couple of minutes. And the calculation result of a measure is not saved into the model. That means that if you create measures, the Power BI file size will not increase. And the refresh time will not increase because it's only the formula which is stored there. And first, when we request a certain visual showing the numbers, then it's calculated. This also makes sense because there's one formula, but the result is always different. Think of a pivot table with the years in the columns and product categories in the rows. Of course, we see different numbers for all those cells in the pivot table because they are filtered by certain years and different products. And therefore, the number is always different even when the calculation formula is always the same. And they behave the same in Excel and in Power BI. So it's a good idea to have measures defined in your Power BI model. And Analysis Services Tabular, by the way. So the margin in percent. This did not work really good out with our calculated column. With the measure, Now everything is in blue and I have this measure icon up there. The measure looks at the whole table, so there's not just one value for the margin or one value for the sales amount, but there's potentially a long list of margins and sales amounts. So we have to tell the measure what to do with the long list. So we have to aggregate the values. In this case, I'm asking for the sum of the margin divided by the sum of the sales amount. If you try to define a measure and start like writing your column names, you will not get like this syntax, how's it called? I can't remember. So it's suggesting like the names. It will not do unless you write an aggregate function. So every time you start writing DAX and you not get any suggestions from Power BI, rethink, because probably it's not possible to access the object right at the moment, for example, without having an aggregate function in place. So again, our example with those three sales amounts, and then we have like 10 divided by 50 is 20, 45 divided by 120 is 37, 150 divided by 500 is 30, and then in the total we have indeed the 30.6 like we calculated, because a measure is always calculated horizontally. So the measure is also calculated for the totals. There's nothing different like calculate some things horizontally and the other things are summed up. No, the same formula, only the context is different. So the context for the first three rows here is influenced by a filter on date, like the 1st, 2nd, or 3rd of July, and the only difference in the total is there's no filter on the date column. So it's calculated for the total of the margin divided by the total of the sales amount, and this gets us the right number, 30.6%. The margin can also be calculated in a measure. We can subtract the sum of the sales total cost from the sum of the sales of sales amount. This also works. 50 minus 40 is 10, 120 minus 75 is 45, and 500 minus 350 is 150. Again, remember, for the measure, this is also done on the total. So it's calculated as 670 minus 465, resulting in the 205. Again, in this use case, we could calculate it as a sum of the margin, or like replicating the formula also on the total level. The measure always calculates it on the total level without any filters applied. This is very important because sometimes this can be confusing, because people also try to recalculate the margin as a sum of this. For this use case, no problem at all. But think of use cases where one entry, one fact could be assigned to 2 or more dimensions. Then you see like, think about insurance. So somebody has knee problems, another person has back problems, and the third person has knee problems and back problems as well. So if we make up a report on the counts showing how many people have knee problems, that's 2 people. Then how many people have back problems, that's also 2. But on the total, we show then only 3, because it's only 3 people sharing some of the problems. This is very important to remember. So if if you or your report users expect that the number is calculated differently, we cannot just calculate like we see here, but have to reach out on a trick we will see in the next example. So the margin, not the sales amount. The sales amount is calculated as the price times the quantity. If you do this with a measure, we see that 30 times 4 is 120, 30 times 4 is 120, 100 times 5 is 500, and then we have a sales amount, a total of 2080. This would be really nice, but unfortunately it's just not true. We would expect like the sales amount is the sum of those 3 values we see on the screen. What we defined instead is that we asked for a measure calculating the sum of the price times the sum of the quantity. That means the 2080 we see on the total line for the sales amount column is 160 times 13. And this doesn't make any sense, because summing up the price is like mixing up apples and oranges and doesn't make any, not useful in this use case, I would say. So this calculation is just wrong. We cannot calculate the sales amount in this way, that we just remove some context and then replicate the sum of the price times the quantity. So what can we do here? What we need is, we need a calculation that's done for all of the rows, like price times quantity, not sum of price, but price times quantity, for the whole sales table. So for all 4 rows. So like 10 times 3, 20 times 1, 30 times 4, 100 times 5. And when it's finished for all the rows, it should sum up all the results. So like we're mixing now, we're calculating things on row level and other things as a sum, as an aggregation over the results. And that's what we can do with the sum x calculation. So sum x stands for, x is like a hint that is an iterator function. I will always say like x like iterator to make fun of it. I don't know really why it's x for extended or something like that, probably. And sum x sums the aggregated value up. So the aggregation is then a sum. There's also like a min x or a max x or an average x or product x, and there's also a concatenate x. I think that's all of the calculations. They all always then show, for example, the minimum value of the calculated values or the maximum one, or calculate an average on that. And this solves our problem because we need to calculate price times quantity on row level, so within the row context. And when it's done, then we have to sum it up. And that's what the x iterators functions are for. So let's take a short break and rethink what we learned. So sales amount is price times quantity. Can we calculate in a rightful manner the sales amount as sum of price times quantity? And or can we calculate the sales amount as sum of price times sum of quantity? Think a moment before you decide. And there's only one option right, because the sum of the price doesn't give any sense. We cannot sum up prices in a meaningful way, so this calculation would be wrong. And the good news is the first one, the right one, can be calculated in measures and in calculated columns as well. So this is easy to do. The second one could only happen in measures. And if this happens, then rethink it's not possible to sum the elements up, but we have to sum up the single calculation. So we have to reach out to the sum x function. The margin can be calculated, that's the question to you, as sum over the differences of sales amount and total costs, and or can be calculated as the sum of sales amount minus the sum of total cost. So it's one or both right. Think again, and yes, both are right. So we can calculate it in both ways because we can always exchange plus and minus. Doesn't matter if we first subtract something and then add up something, or if we first add up something and then subtract something. That's the rules in mathematics. And then we have the margin in percentage. Can we calculate the margin in percentage as the sum of the margin divided by the sum of sales? And or can we calculate the margin percentage as the sum over the results of the divisions, like margin divided by sales amount, and then sum the values up? And I'm sure you got it right. Only the first one is the right one. The second one doesn't really work. And the first one is only possible in measures. So if you want to calculate percentages, ratios, something like that, then you cannot calculate this as a calculated column. And you cannot pre-calculate it in Power Query or in your data source. You have to calculate this as a measure in your data model if you want the right results. So the takeaways from this session are: you should take special care of your numeric columns. And it doesn't matter if it's ordinary columns or calculated columns. Always check them and treat them well. And treating them well means if it's something where the default summarization only makes sense if you set it to do not summarize, like the price, we should not summarize prices, like the year or the month. Like if you have this effect that you take the year and put it on the canvas of Power BI and suddenly you see a big bar chart showing a tremendous high number, and then obviously I would guess that your calendar year is marked with an aggregation sum instead of do not summarize. So please mark all those elements with do not summarize where it doesn't make sense to have aggregations. For all the others, create measures so that you have an explicit measure defining how the calculation is done, like a sum or average or count, whatever, and hide the original column. So hide the column from your users. That means the column is still there in the data model If you already have reports depending on this column, it will work. All your DAX measures will work. It's just not apparent in the UI that this column exists, and so people will not use it but use the measure instead. And I would not create any calculated columns at all if you ask me, because when I have to calculate something as a column, if I need it as a column, then I would do it as early as possible. And before we load it into the data model, there's one step, the Power Query. We could calculate this in Power Query. Yes, I know this is a different language, Power Query, mashup language, different syntax to learn, but there's a lot of UI functionalities, so it should be easy for you to calculate. Or I would push it even if you load, for example, data from your data warehouse, or somebody prepares some CSV files, Excel spreadsheets, whatever, ask them that they prepare it beforehand and then you load it from there. So they change it once instead of you edit it every time. And the only reason why I would add something as a calculated column, I see in two things. One is you cannot filter on measures. So if you need a report showing only sales greater than something, this is not possible with measures. You have to calculate this as calculated column, then you can put a filter on it. Most probably I would suggest not to put directly a filter on it, but like make up buckets, so that you, for example, have small sales amounts, medium, big sales amount, or whatever of your choice, and then you filter on those. So you only want those sales amounts within those buckets. And the other one reason would be that some of the visuals still do not allow to use measures, so you have to have it as a calculated column. Then, of course, there's no way out. If you want to visualize it, then with these visualizations, then you have to make a calculated column out of that. So we are almost half through, or first half through, so we talk about the next level. So I hope you understood everything. If you're watching this recording, it's a good time for a pause, relax, rethink everything, and then we go to the next level. So what is the next level I suggest? This is more of educational stuff. It's not because I do this regularly, it's just to give you a feeling how DAX is thinking and is working. So next level would be, what about using an iterator function like SumX inside a calculated column? Previously we used it in the measure, and we should try out what's happening in a calculated column. And the other one is, what happens if we put a measure inside the calculated column? You know, calculated columns are pre-calculated during the refresh. Measures are not. Can I use a measure there? Let's try it out. So this is again a calculated column, orange. Everything is in orange. That means we are talking about a calculated column. And what I created here is a calculated column named sales amount SumX, because the content formula is here that I do not calculate price times quantity, but I put this into the iterator function SumX. And the question is, what shall we expect from that? Is it like the sales amount like we would expect line per line, or is it something different? And the news are, it is something different. So what we get is, we get 670, which is the total of the sums of the sales amounts in each row. And the reason for that is because this iterator SumX is calculated for the first column, for the first row, for example, and for the first row is calculated for the whole sales table. So so the sales table here is not filtered by the current row context. This could come as a surprise or not, but this is the way DAX works. And this is very important to memorize, that a row context does not influence does not translate to a filter by default in this case. So the sales table for this iterator is the whole sales table, so all 4 rows. That means when it's calculated for the first row, it takes 10 times 3 plus 20 times 1 plus 30 times 4 plus 100 times 5. And this ends up at 670. And the same is then repeated for the next row. The next row is also iterating over the whole sales table, because the sales table here in this iterator function is not influenced by the current date, for example, but the date of the current row. Remember, calculated columns row context is not filtering the sales table inside a SumX, because the row context is not filtering. what if I put the sales amount measure inside a calculated column? This is allowed syntactically. And remember, the sales amount measure is exactly what we just tried out. The sum x over sales and sales price times sales quantity. So something which had this surprising effect that we saw the total of sales amount on all the rows. What's happening if we have a measure in place with the same formula? Should we expect the same or something different? The thing is, it's something different. So here we see per line 10 times 3, 30, 20 times 1, 20, 30 times 4, 120, 100 times 5 is 500. So now the row context obviously was transferred to a filter context. So the sales table in our example here is now filtered by the current date, for example. Why is that? Because a row context is implicitly, so we didn't ask for it. Power BI or DAX just does this for us, implicitly transitioned into a filter context. And this is only done because we are having a measure there. So if you have a measure, then this measure gets the actual, the current row context as a filter context. So the row context is transferred into filters. So the measure doesn't see all of the sales table, but only the current row. This is how they implemented it. And this is one of the reasons why I ask you always when you refer to a measure to omit the table name. So sales amount without the table name. If you refer to a column, do not omit the table name, write always the table name, even if it's not necessary in this use case, because we want to know if in a calculations formula, are we facing a measure or are we facing a calculated column? Because for a calculated column, the row context is not transitioned into a filter context. For a measure, the row context is transitioned into a filter context. And this makes a different outcome of the calculation. So it's rather important to know at all time, are we facing a calculated column or are we facing a measure in our formulas? So how can we write then calculate the sum x inside of a calculation in a calculated column? We can do this, so I can put the sum x sales price times sales quantity. If I put this into calculate, so calculate is one of the very, very complex functions, and this does different things. And one thing is that calculate always transfers the current row context into a filter context. So if I wrap my sum x sales price times sales quantity function call into calculate, I end up with the same effect like I have when I put a measure, if I put a measure into the formula of the calculated column. So calculate explicitly, at least if you know that it does it, explicitly forces a transition from a row context into a filter context. So this is row context and filter context. So this time we get the numbers, the sales of the current row into this new calculated column. Because calculate performs a transition of the row context into a filter context. So takeaways from this section is that the calculated columns can reference other calculated columns or other columns. This is done row by row, so there's no aggregation, nothing done. We're just referring to other attributes of the same row. The row context is not filtering a table because it's only a row context. I'm at the current row, but if I then reach out to a table, then the table is not filtered by the row context. When we use calculate, then we're asking for, or calculate does for us, that it transitions the row context into a filter context. And we can imagine that every time we use a measure inside a row context, like inside a calculated column, that it's implicitly wrapped in calculate. If we write it or not, it's implicitly wrapped in the calculate. That means that the current row context is transitioned into a filter context. And that's the reason why we should include a table name when referencing columns, because then we know the row context is not transitioned into a filter context, and we should omit the table name when we're referring to measures, so we know, oh, this is a measure, and a measure inside a row context is always only seeing the current row, because the current row is transitioned, the row context is transitioned to a filter context. And the other reason why you should not use the table name when referring to measures is because the measures live somehow detached from tables. So we can easily just grab the definition of a measure and move it to a different table, and this will work without any problems, except if you have formulas referring the measure with the table name on it. That's the reason why you should not use the table name, so we are freely to move the measures around. One reason to move measures around could be, like, some people prefer having the measures in the fact table, so like the sales table, where you have like some sales attributes, like an order number there, that you want also see like the sales amount. And other people prefer to having all the measures at top of the UI and the field list, so in a special dedicated table, which is not really a table, doesn't contain any rows, but contains all the formulas for the measures. And sometimes you want to move around between those, and then it's a good idea not to have the table name in the reference to a measure. So let's go one level further. So what's the next level? Next level, we will reuse calculate. So we learned that calculate is transitioning the row context into a filter context, but calculate can more. It can manipulate the current filter context. So for example, I have a measure called product A. So product A is defined as a reference to sales amount, but I wrapped it into calculate. Remember, if we have calculate, then the row context is transitioned into a filter context. This doesn't make any difference here, but I use a second parameter in the calculate. So the first parameter is now an expression, very simple, only reference to another measure. And the second one is a filter. So I state that I only want to see products with product description, where the product description is A. And the question is, what kind of effect has this on this product A column? What we get is that no matter which product I show in my table, I always see in this new column with product A only the sales amount of product A. So we see product A has 30, product B has 140, but in the column product A, it's showing the sales amount of product A. So what this filter condition in calculate indeed does is that it overrides the current filter context. So because in the second row, where we see product B, there is already a filter on product B, and this leads to a sales amount of 140. But in the column product A, this filter on product B is removed and replaced by a filter on product A. That's why we see product A in all the columns. And again, remember, the measures also calculated in the total. So the total is not a sum of those 4 times 30, but the total also shows 30, because the total only shows what the measure shows without any filter on the product table, but product A introduces then a filter. So that doesn't have to remove a filter on product description because there's no product description filter in the total. But it then introduces the filter on A. That's why we see also 30 in the total row. So calculate can filter an expression. So that's two things we learned about calculate: transitioning the row context to a filter context, and also to manipulating the filter context by, for example, filtering an expression. We can also write the same expression. That's why I named it product A version 2. So the same effect is if we write calculate sales amount, product description is A, but add a filter here. So this makes it more clear what calculate does. So if I write it like that, calculate will rewrite it like that. And this makes it much clearer what's happening. So the second parameter is not directly a condition, but a call to the filter function. And the filter function returns a table consisting of some rows. What kind of rows? The first parameter of the filter expression, of the filter function, is also referring to a table. What table? In this case, it's the product description of products, but not just the current filter context, but all of them. So all product description shows all the product descriptions of the table product, no matter if there is a filter on the product table or the product description column. And then introduces a new filter on the product description where it should be A. So I think this is longer to write, but easier to understand what's actually happening. So this logic or this syntax is hiding away some of the complexity. This makes it more transparent what it is, but both things, this one and this one, are doing exactly the same. So in both ways we get a new column or new measure showing only the sales of product A. The calculate filters the expression via implicit filter all on the expression. If we only want to see a value of when the product is A, we can do this way. So we can also reuse the filter, but then omit the all. So now we're referring to the product table. So calculate sales amount filter product. This is the product table in the current filter context. So if there's an existing filter on the product table, this will stay. And then an additional filter is applied on the product table. So this is like the existing product description, and it has to be A, like this one. So in the first row, we see the product actually is A, so the sales amount is 30, and the last column, product A only, so shows 30, because this requests DAX to show all the rows where the product description is A and A. A because it's already in the filter context of this table, and A because I added it and in the filter condition of my measure. In the second row, product B, the product A only measure is empty because the existing filter context is on product description is B, and then I add another filter on product description where it should also be A, and we don't have any sales for single sale. The product was A and B. That's why it leads to an empty value. The same is true then for the other rows showing for product C and D. So the total still 30 in all the cases, because the total is just calculating without any existing filter condition, filter context, and this means we stay at value 30 because we are requesting only the sales where the product description is equal to A. So without all, the filter combines all the filters, the existing filters, with an AND operator. So it has to fulfill all the existing plus the new condition, and that's why we see 30 in some of the rows and nothing in the other rows. Product all. This is a measure where I ask calculate to calculate the sales amount and removing all existing filters on the product description. I'm not adding a filter, an additional filter, but just ask calculate for removing all the existing filters on product description. So this way we end up with a column showing us the total of the product sales. So 670 is the total, the total for the sales amount column, and it's the value for all the rows in the product all measure, also for the totals. This measure, as we see it here, will not be very useful, but it's very rare that we have to show totals in different rows. But where this comes in very handy is when we have to calculate like percentages, like calculate what's the percentage sales amount for product A compared to the total. So this way we can like divide 30 by the 670, not because I can refer to the total, but I can calculate another measure showing the 670 and then I can calculate it, or I could just write a measure like sum of sales amount divided by calculate sales amount over all product descriptions. So this way we can calculate this in just one measure. So all removes all the existing filters. And usually if you want to write performant queries, don't use only the table name, but also put the column name there. This is much faster. Maybe in some cases you need to clear all the filters for the whole table, no matter if there's a filter existing on one of the columns. But if you only put one column there, it will be much faster. In some cases, there is already a filter applied, for example, on the product description, in a slicer, for example. And then the question is, shall I show all the sales amount for everything existing in the product table, or only for those pre-selected in the slicer? And all selected helps us with that. So as you can see here, the new column product all selected only shows 140. Why is it only 140? Because the measure asks for all selected product description, and all selected, there's some built logic built into the product, so it can find out that there's a filter outside of the current visual. So there's a filter in a slicer asking only for product B, and all selected stays influenced by this filter. So it's not removing all the filters from all the product descriptions, but it's only removing the filters for some filters existing inside of the measure, but not those outside, not measure, inside of the visual, but not those outside of the current visual. So which one is right, showing 670 or 140, or like calculating the percentage against 670 or 140? Depends on what your user or what you expect. So there's no right or wrong answer. I see that in many use cases, people expect a result like we see here with the all selected, but that must not be true, or doesn't have to be true for all the use cases you are facing. So all selected alone removes the filters from only within the visual, but not the filters existing outside of the current visual. So the takeaways of the third and last level is calculate is very powerful. It can do two things. It can add and remove filters, and it can also transition the filter context. A filter in calculate, if you just put it there as a condition, always overrides an existing filter on the same column. So like putting a calculate measure and then a condition, this leads to the expression that it will filter all the columns and then add this expression. So all the existing filters are overwritten. And all in calculate can remove all the filters on the table or column, and so we can reach out in the calculation down to the total of the table. And there's all selected, and all selected only removes the filters from a table or column, but keeps the filter which are existing outside. So if there's a slicer or something like that, this filter will be accepted and stay, will not removed, and therefore we get a different result then. So let's wrap it up. So DAX has an easy syntax, but a rather complex semantic. And this complex semantic sometimes scares people away, but it's really necessary for complex calculations. Of course, in the beginning probably we will not start with complex calculations, so this complexity seems like an unnecessary thing, but it really helps to fulfill to make up with for powerful measures and calculations in your models. I would recommend to not create any numeric calculated columns if you need them, for example, because you have to filter on them, or some of the visuals you want to use only accept columns and not measures. then you of course have to calculate them, but not in DAX. I would prefer then to calculate them in Power Query or in the data source. And you should create a measure for all the calculations. That's what I would recommend by default. Of course, there might be exceptions, like performance tuning can sometimes be better if you have a measure. Sometimes it's better you have a calculated column. This is sometimes a little bit tricky to find out. But as a general rule, I would create measures for all your calculations where you apply the correct aggregation and hide the original column. So I will not show, by default, I do not show any numeric columns to my end users. I only show them measures calculated upon those calculated columns, and then I will hide those columns so they only see the measures and work with them. You should always include the table name when referencing to columns. The reason is we want to know that we are facing a column, and you should always omit the name of the table when referring to a measure. Once is because we want to see this is a measure. We want to really know that this is a measure because row context transition happens automatically with measures, and sometimes we want to move around the measures, move it onto a different table, and this is only possible if you didn't refer to the measure with the table name. With that said, I say thank you for attending this session, and I will be there for the rest of this session and answering your questions. So please make use of the Q&A functionality. I wait for your questions and looking forward for them. Thank you very much.